Hello guys, welcome to my YouTube channel. Today we are gonna learn about how to find arc length of a curve which is not a smooth curve. So if we remember the definition of smooth curve, it is a curve having first order partial derivatives continuous. That means dy by dx is continuous. Okay. If the function is not a smooth curve, then how to find arc length of this curve? Okay. So, what are the steps here? So, the first step is to convert the function from y equal to f of x to x equal to g of y. Then the second step involves to convert the limits according to x, that is to find limits of x. Then comes to the third step, which is applying the formula, which is L equal to C2D 1 plus dx by dy whole square. Okay, so now let's take an example and find arc length of this curve. Okay, so for example, I am taking a curve y equal to x by 2 whole to the power 2 by 3, where x is from 0 to 2. Okay, so we have to find the arc length. Okay, so first step, we have to check if this function is smooth curve or not. Okay, so if it is a smooth curve, then we can use the method 1 formula, okay, which is L equal to a to b root over of 1 plus dy by dx whole square into dx. Okay, so first step, let's check whether it is a smooth curve or not. Okay, so let's see what is the value of dy by dx. Okay, now see here, what is the constant term here? Here the constant term is 1 by 2, so the constant term will go out of the derivative. So this term is 1 by 2, 2 by 3 into derivative of x to the power 2 by 3. Okay, if you are not getting these terms, how we got this one, then you can use the splitting format, okay, which is dy by dx. I can write this as d by dx of x to the power 2 by 3 divided by 2 to the power 2 by 3. Now here this 1 by 2 to the power 2 by 3 is a constant term, then it will go out of the derivative and we will get this result. Okay, so now let's solve furthermore. Now this is 1 by 2 to the power 2 by 3 and this is derivative of x to the power 2 by 3 with respect to x, which will be 2 by 3 into x to the power 2 by 3 minus 1. Here we are using the formula derivative of x to the power n with respect to x, which is n x n minus 1. Okay, so now let's see what happens here. It is 2 to the power 2 by 3 and this is 2 by 3. This value is x to the power minus 1 by 3. So here there is no need to solve this constant part, as our focus is to find whether this function is continuous or not. Okay, so just leave these terms here. Now what is this value? It is x to the power minus 1 by 3. I can write this term as 1 by x to the power 1 by 3. So see, now this function 1 by x to the power 1 by 3, it is not continuous. Okay, so this is not continuous at x equal to 0. For that reason, y equal to x by 2 to the power 2 by 3 is not a smooth curve. Okay, so if it is not a smooth curve, then we will use this second method, which states that convert the function from y equal to f of x to x equal to g of y. That means we will do here the first step as converting this y equal to f of x to x equal to g of y. So simply we will rewrite this function. So what is this value? First, let's take the power to the left hand side. Okay, then this power 2 by 3 will go to the left hand side, and this will become y to the power 3 by 2, and this is x by 2. Now write this x as 2 y to the power 3 by 2. So now see, this function is a function of y. Okay, so now we have also to find the limits, which is in the second step. So we'll move forward to the second step, which states that find the limits for x. Okay, so now see, what is the limits for x? Now we have given the limits of x are 0 to 2. Okay, so now we will find what is the limits of y. Okay, so use these values here and find the y's limits. Okay, so first take the lower limit. When x equal to 0, then y value will be 0 by 2 to the power 2 by 3. Now this value is 0 to the power 2 by 3, that is 0. Now take the upper limit. Upper limit is x equal to 2. So now this y value will be 2 by 2 whole to the power 2 by 3, that is 1 to the power 2 by 3, that is 1. So now we have got the value of y accordingly to x, which is 0 less than equal to y less than equal to 1. So now we will find the arc length now. So what will be the arc length formula? Here the formula is c to d 1 plus dx by dy whole square into dy. Okay, so before solving, let's first find out this value of dx by dy. So we know this x is 2 y to the power 3 by 2, and we have got this from the step 1. Okay, see, from the step 1 we have got x equal to 2 y to the power 3 by 2. Now find the derivative with respect to y. So see how to find out this derivative. Now here, which is a constant, 2 is a constant. Okay, so 2 will be going out from the derivative. So this value is 2 d by dy of y to the power 3 by 2. Okay, so now let's find this derivative. It is 2 into derivative of y to the power 3 by 2 with respect to y. This will be n y n minus 1. So where do we find this formula? We are using the same formula as that of x. Okay, that is derivative of x to the power n with respect to dx, which is nx n minus 1. Instead of x, here we have the function as y. Okay, So on simplifying, we get this expression as 3y to the power half, and we know y to the power half is equal to root y. Okay, so now we will use all the values in the length formula and see what is the value. So let's see the formula for L. Here it is C to D. Okay, so C to D is limits of y. So what are the limits of y? It is from 0 to 1. Okay, so this limit is from 0 to 1. Then root over of 1 plus dx by dy. So what is the value of dx by dy? And here this dx by dy equal to 3 root y. So square of this value and the root over into dy. Okay, so now let's solve furthermore. What is this value now? This is 0 to 1. It is 1 plus 3y, sorry, 9y into dy. Now we will use the method of substitution. Okay, so how to substitute? Now let us take the inside part of this square root as t. Okay, now differentiating both sides with respect to y or t as your own interest. So I am doing this with respect to y. Okay, so that this value is d by dy of 1 plus d by dy of 9y. Right side is dt by dy. Here our objective is to find the value of dy. Okay, so now see, derivative of 1 with respect to y, it is a constant, so its derivative is 0. Then here derivative of 9y with respect to dy, here 9 is a constant, so it will go out of the derivative part. Now this derivative. Okay, so what is this value? This value is 0, this is 9. Then derivative of y with respect to y, it is 1, it is equal to dt by dy. So now this dy value is equal to dt by 9. Okay, so now we will find the limits according to t. Okay, here the integration values are from 0 to 1 for y, so accordingly we have to find the limiting values for t also. So what will be these values? Now here apply when y value is equal to 0, so t value will be equal to 1 plus 9 into 0. Okay, we are using this same expression, and this value will be 1, and we'll put the upper limit is 1, so we'll apply this value here and we will get 10. Okay, now we have found both the limits for t. Okay, so now let's substitute again. So what will be the value of L? Now here first put the limiting value. The limiting values are of t values, so t is ranging from 1 to 10. So integration values from 1 to 10. Then let's see the integration again. Here root over, then 1 plus 9y is equal to 2. So inside value is root t. Then what is the value of dy? Dy value is, here we have found already, dy value is dt by 9. So see, now this 1 by 9 is a constant. It will go outside of the integration. It will be 1 by 9. Then 1 to 10 root t dt. Okay, so now see what is this root t. We know root t is equal to t to the power half. Now what will be the integration? The integration value will be t to the power half plus 1 by half plus 1, and limiting values are from 1 to 10. So how do I got this formula? Now this is again the standard formula, x to the power n dx, which is x to the power n plus 1 by n plus 1. Okay, Here there is a constant value, but here as it is a definite integral, so there is no need to add a constant value. Okay, so now let's solve furthermore. It is t to the power 3 by 2 by 3 by 2 and limits are from 1 to 10. So again let's take out this common factor, so it will be 2 by 3 into t to the power 3 by 2 and limits are from 1 to 10. So what is this value then? See, this value is now 2 by 27 into, now use the limits. Upper limit is 10 to the power 3 by 2 and take the lower limit as 1. So this value is 10 to the power 3 by 2 minus 1, which is the required arc length of the curve. You can furthermore solve this expression using the scientific calculator. Now if you want more problems on this type, then I will share the images of such problems in the end of the video.